In problem number 4, we need to figure out information about the local extrema and the critical values of the following function. So what we're asked is, how many critical values does this function have, and are they local mins, maxes, or neither? So in order to answer any of those questions, we need to take the derivative of this function. So to find the derivative of this function, we're going to have to use the quotient rule, because we have a division of two different types of functions. Nothing can be canceled there, and changing the denominator to a negative power and doing product rule in this case wouldn't really make it any simpler. So we're just going to do quotient rule. So we do the derivative of the top. The derivative of e to the x is e to the x times the bottom minus the derivative of the bottom times the top. Well, again, we're going to have times the top, so we have e to the x again. But now we're doing the derivative of the bottom. So the derivative of the bottom would be 2x minus 1, doing each of these terms. So we put that all over the bottom squared, 1 minus x plus x squared squared. And that's our derivative, not simplified yet. We can do some simplification really simply in the numerator, because both of these terms have an e to the x, so we can factor that out. And let's write what we have left, but let's write it in order of decreasing degrees. So we have an x squared here. We have minus x and we have minus 2x, so we get minus 3x. And we have 1 minus negative 1, so we get plus 2. On the bottom, we still have 1 minus x plus x squared squared. So by factoring, out the e to the x's in the numerator, we're able to combine like terms down for the rest of the things. And now this can also be factored. We can do one more step here. So x squared minus 3x plus 2 is x minus 2, x minus 1. And here we have 1 minus x plus x squared squared. Notice that this bottom part, the 1 minus x plus x squared, even if you wrote that in decreasing order, that's not something that factors into whole numbers. In fact, it doesn't have any real factors anyway. So this is the factored version of our derivative, and we wanted that because now we can answer the question, how many critical values does it have, and are they local mins, maxes, or neither? Well, remember, something is a critical number of a function if it makes the derivative equal to 0 or undefined. In other words, if it gives me a horizontal tangent line or a vertical tangent line, then that's a critical number. So we need to figure out where would the numerator or denominator of this derivative be 0. Well, e to the x can never be 0 because that's a property of that function. The denominator, it may or may not be 0, but we actually don't care if it does, because even if this denominator ended up being 0, that would have meant that the denominator in our original function would have been 0, because that's just this squared. But if the denominator in the original function was 0, then that point would not have been in the domain anyway, and it couldn't have been a critical number. So remember, critical numbers have to exist on the function. So what I'm getting at, if any x value makes this denominator 0, it also would have made the denominator of our original function 0, and therefore it's not in the domain. So even if it's possible for this to be 0, we don't care, because it wouldn't be in the domain, therefore it's not a critical number. So therefore, we only care if the numerator can be 0 based off of those two terms, which that's really simple. This is x equals 2 and x equals 1. So those are our two critical numbers here in this function. So how many critical values does it have? It has 2, and they're x equals 2 and x equals 1. So then the second question are they mins, maxes, or neither? In that case, we need to do our first derivative test and set up a number line. So our only critical values are 1 and 2, so that's all I'm going to put on the number line. And remember, for this, we just need to check what's happening on either side of these, because if the derivative is positive, then we know that the function is increasing. If we know it's negative, then it's decreasing. And how the increasing and decreasing connect, that tells us if they're maxes or mins. So let's just try a number less than 1, like 0. If we plug in 0, by the way, we don't need to check the e to the x or this denominator, because this is always positive, e to the x is always positive. That's never going to change anything. So really, we're only checking these two. If we plug in 0, we get negative times negative, which is positive. If we plug in something that's in between 1 and 2, it doesn't really matter what it is. This term would be negative, but this term would be positive, so we get a minus. And if we plug in something bigger than 2, they're both positive, so we get positive. So therefore, at all values up to x equals 1, this function is increasing. But then between 1 and 2, it's decreasing, and then after 2, it's increasing again. So that tells us that at 1, it changed from increasing to decreasing. So that tells us that we have a max value at x equals 1. I'll write that right here under where I wrote x equals 1. And at x equals 2, it goes from decreasing to increasing, so that has to be a min. So we have two critical values. The one at x equals 1 is a maximum, and the one at x equals 2 is a minimum.
The Teaching Center, UF's Learning Resource Center.